So let's go over the topics that we are going to cover in this course. So today we are going to cover code quality and coding convention, these two topics, and we don't have a lab for this. And next week we are going to cover check style, and then PMD, find bugs, and sonar, and code pro. So these are code quality analysis tools. And after that, we are going to move on to build tools and version control. So starting with Maven. So we are going to cover Maven basics, and then we'll cover Maven advanced topics, such as multi-module support and POM inheritance and profile and things like that will be covered in Maven advanced topic. And Nexus is a repository server, so we are going to cover Nexus as well. Then we are going to cover JIT and GitHub as a source control management system. And then we are going to cover continuous integration server. In this case, we are going to cover Hudson. Then OneJar and ProGuard are some of the utility tools for building your jar files. And in terms of testing, we are going to cover Mockito, I would say the most popular mock framework, and Selenium and Fitness and Aquilion. We might in fact add a couple more topics on the testings here, but these are the topics that we are going to cover in this course. Any questions on course contents? Okay, so if you don't, let's actually move on to code quality presentation. Again, today is just a presentation because we don't have any lab, and in fact we're going to do labs from next topic, from next week, starting with a check style. So let's talk about the code quality, and these are the topics we are going to cover in this presentation. So why we should care code quality? Of course, this is kind of an obvious question. And with the obvious answer. So something to think about. Programs must be written for people to read and only incidentally for machines to execute. What that means is that code is supposed to be consumed mostly by developers like us for reading and understanding and writing and changing and things like that. The time the machine is in fact due with the code is very small. Most of the time we are actually digesting the code. Now, cost of defect. Again, this is kind of obvious. The earlier you find the defect, the better. And in fact, the cost of fixing a problem during production time is 100 times more expensive. So the earlier you find the problem, the better. So let's talk about some of the statistical information regarding software defects. So these are the statistics regarding software defect. So as I mentioned before, finding and fixing problems in production time is 100 times more expensive than during requirement and design time. Now, 40 to 50% of typical project work is avoidable work, meaning we do not have to do 50% of our time. 50% of our work because those things could have been avoided. Now, 80% of avoidable rework comes from 20% of defects. And 80% of those defects comes from 20% of the modules. And 90% of downtime of the application comes from at most 10% of defects. So we are basically talking about a very small percentage of your code is causing most of your problems. Peer reviews catch 60% of defects, and perspective-based reviews. By the way, perspective-based review is something like each reviewer takes a role, like a user or tester and things like that. These perspective-based reviews catch 35% more defects than non-directed reviews. If you think about it, as a developer, when you look at your code, you have a tendency of not seeing the problem, right? So that's the reason we need someone else with a fresh eye and different kind of perspective looking at your code. Disciplined personal practices can reduce defects by up to 75%. So even though we know all this, we still do not follow the rules of engagement in software writing, and why that is the case. Meaning we actually do over and over the same problem. I mean, basically make the same mistake over and over. It's just like you know that you have to eat the right thing and you should not smoke, but we still do. Same thing happens in software development, unfortunately. What about the QA? Aren't they supposed to catch all these problems for us? No, that's not the role of the QA. So QA should not care about the quality of design and implementation. That's the jobs of developers. Instead, QA should actually do the testing that matter: functionality testing, acceptance testing, performance testing, and usability testing. And that's the areas they should actually focus their effort, rather than actually solving the problems caused by the developers. So basically you should actually give a better quality software to QA so that they can focus on those testings that matter, such as, again, functionality testing, acceptance testing, functionality testing, and usability testing. Okay, so I'm sure you have heard the term technical debt. So what is a technical debt? Technical debt is something like something needs to be done, but you just let it go. Those tasks are not being done. For example, refactoring, upgrading, and conforming to coding standard. My mistake on T here. Coding standard and things like that. And technical debt is like a real money debt. It grows on you. So eventually, it's going to cause a lot of problems from the standpoint of your code quality. So how to improve software quality? So, start software quality process as early as possible. Don't compromise, and schedule time to lower your technical debt. Take time to, reduce your technical debt. Make it work, make it right, and requires monitoring and changing behavior, and also willing to help and be helped. So some of the principles, some of the these are kind of guidelines that you should keep in mind. Okay, individual effort, you should care about the quality of your code, of course, and following, for example, like a good names for variables and methods like this coding convention we're going to cover in our subsequent presentation. Short method and smaller classes, and you want to make it simple. What that means is that you are reducing complexity of your code. Write tests with high coverage, and of course, high coverage testing is very important. Run your all tests before checking in, check in frequently, and ask for feedbacks. So these are kind of principles, and later on, in this course, we are going to in fact use tools to measure how you are doing in terms of these guidelines or principles. Team effort, avoid shortcuts, take collective ownership, and promote positive interaction, provide constructive feedback, constant code review. Again, these are pretty much guidelines and principles. Broken window problem. This is actually an interesting phenomenon. So study shows that broken windows lead to vandalism. So if you happen to have a code and no one cares, and those code will deteriorate quickly, so you do not want to actually leave the code broken, meaning you want to fix it as soon as possible. So that's the idea. Treat warnings as errors. Don't say this is only a warning. So you want to take a look whether that warning is really benign or not. And if it is benign, you want to suppress it so that next subsequent warnings, you can actually take a fresh look. Strive for higher cohesion. So cohesive code is focused and narrow and small. So it does one thing and one thing well. So it actually following single responsibility principle. So in fact, a lot of tools actually give you a sense of in terms of this cohesion through what is called the lower cyclomatic complexity. So this is basically indicating complexity of your program by having a measurement on the number of linearly independent paths through your program source code. So we're going to actually take a look at some of the tools that does measure this cyclomatic complexity. For example, Google's Code Pro and a few other tools. And having this one thing, the cohesive code will actually have less expensive to maintain, and change in this low cohesive code. Yeah, so if you have a very low cohesive code, then it will actually break things. So if you make a change in one place in this low cohesive code, and it's highly likely that it will actually break something else. So you should actually strive for higher cohesiveness in your code. And this cohesive principle applies to all levels: method, class, component, and subsystem. Okay, code quality checking. So how much of your code is covered by test? Should actually cover 100%. How about path through your code? Is there code that deserves not to be tested? If there is a code that deserves not to be tested, then it should be in fact removed. So code coverage tools, in fact, we can actually cover some of these things. Clover, Covetra, and Jacoco. These are the tools that give you a sense of in terms of how much code has been tested. And in fact, some tools actually delete code that have no test. That could be a little bit extreme, but you see the point. Oops. Cyclomatic complexity. So again, we talked about this concept a bit in a few minutes ago. So basically, number of distinct paths through code is called cyclomatic complexity number. So again, you should actually strive for lower CCN, and that means you're creating highly cohesive code. The tools that can measure this cyclomatic complexity, CCN, is PMD and checkstyle. Code duplication. Duplication code is expensive to maintain, so you should actually strive for removing duplication of code. Again, tools such as PMD and Code Pro Analytics will help you to find out code duplication. Code analysis tools, so it can find logic errors and coding guideline violations and synchronization problems, and so PMD and find bugs, those are two popular tools. Coding principles, again, simplicity, clarity, brevity, and humanity. Commenting code. So comments should say why or purpose of that code rather than how, because the code itself should actually provide how part of it. So you want to actually specify the why and purpose part in comment. So basically, we are keeping we are actually following dry principle. Don't repeat yourself. So if you're actually describing how things are done in your comments, and suppose if you change your code, then you have to change the comments as well. So sometimes they might not match. So yeah, that's the purpose. Okay, so that is the end of the presentation. So let's actually move on